hello everyone. Good morning, and I hope you are all doing okay. So, today we are in our lecture number 8. So, before anything else, let us have a brief review on what we had discussed last time. So, it's about naive Bayes, no? So, with Bayes' theorem, it calculates the validity of hypotheses based on available evidence. So we already discussed how we used the formula, no, in the prediction process, of course, with the use of the evidence. So furthermore with this, I'm going to show you, since I missed to have a demonstration on how to do it on the Python code, no, using naive Bayes. So I've already uploaded an example of the file. No? So we have here this 6 steps to train model with Gaussian naive Bayes classifier. So in this example, I've used Pima Indian diabetes.csv. So let's try. Okay, then let's take a view on some of its data. So we have here. So the classification is, of course, as we all know, it classify whether a person has a diabetes or not. Okay. We have the features, and then we have the classes. Then let's apply coupled cross validation. Then let's create a model, and then train and cross validate. Then let's print a result, and of course the accuracy, which is 0.75 or 75%, which is of course a high score or have a better performance. Okay, now today we will be discussing on SVM or support vector machines and artificial neural networks that will be discussed also later. So first, let us have the SVM. So ano ba talaga yung SVM? When we say support vector machines, the objective of this is to find a hyperplane in an n-dimensional space, no? So that distinctly classify the data points. So this n in the n-dimensional space are the number of its features, no? So say for example, sa dataset ng diabetes, so we have the age, the insulin, and so on. So those are the features. So what are the points for discussion for this? So we are going to discuss on the decision boundary or hyperplanes and learn more about support vectors, the kernel trick, and also we'll be seeing an example using SVM scikit-learn in classification problems, and of course as well as in regression problems. Okay, so what is really the core of the algorithm? So as you can see here sa ating diagram, so we have here a decision boundary, right? Here, decision boundary. So this is actually our objective. Find this decision boundary out of the instances on our dataset. So our objective is to find the best, no, hyperplane that would separate the dataset into two classes if of course it has two classes. So for this example, this is a binary classification problem. So we just have to assume that we have two classification in here. And so this problem is actually for a bank. No, so assume nato test nga, you are an owner sa bank, and then you are going to classify whether your client is credit worthy or not credit worthy in accordance with its features. So ano yung features? So we have here the monthly income and then the years spent working. So ito yung dalawang features natin. So for a data set with more than two features, so yung decision boundary naman is hyperplane. Decision boundary. So based on the example, so we have here the support vectors. So these support vectors are data points that are closer to the hyperplane. So yung hyperplane natin dito is this. Okay? And it influenced the position and orientation of the hyperplane. So using the support vectors, we will be able to maximize no, the margin of the classifier. So we can see the margin, iba yung margin kung sa bond paper pa class, it could be on the sides of your content, right? So here, so just imagine that this is our decision boundary. So ang margin natin is actually this part, this one. This is our margin, kana siya nga length plus here as well. Then if you're going to delete the support vectors here, that will change the position of our hyperplane. No? So that is why these are the points, the support vectors that will help us build our SVM. Okay, so we have here two representation of hyperplane. So we have here, for example, this is hyperplane A on the left side, and then hyperplane B on the right side. Now the question is, which hyperplane is better? Now, remember that in SVM, our objective is to maximize the margins. Okay? So this actually, both of the hyperplanes actually divided or separate the two classes, which is of course our objective, no? To separate with those credit worthy and not credit worthy clients. No, but the question is, which will be a better hyperplane? So as you can observe, based on its margin, here's A, graph A, yun. This is graph B. So, kumbaga, ano margin yung mas malaki? Diba? So, of course, itong B, right? So, it has a greater margin than of the first one, graph A. So, based on the two graphs with hyperplane, graph B has a better hyperplane. This one. This. Okay. Now, the question, how does SVM find the best hyperplane? Okay, so just like what I've said, they just have to choose the decision boundary that maximizes the distance, no, to the support vectors. So here medyo ang ang orange one is actually more near with the purple points, right? At itong green line naman, green na hyperplane is more hindi. Itong purple, the blue one, the blue hyperplane rather, is actually more mas ano siya closer no to the orange data points. And of course, as you can see here, meron na tayong answer. So best decision boundary is the green one. No? So hindi siya masyadong close. So the margin between those of the data points is actually maximum siya than of the other hyperplane. So as you can observe, out of the three candidate for decision boundaries, the green is the best decision boundary. So yun lang, ang pinaka-objective lang sa SVM is to find the best decision boundary or the best hyperplane. Of course, by doing that so, you just have to find out which of the following hyperplane has the maximum distance in terms of margin with the um, support vectors. Ayun. So as I've said, the goal is to choose a hyperplane with the greatest possible margin between the hyperplane and any support vectors. Now, how about if the data set is linearly non-separable, like this one? So medyo ano siya, random yung mga points. Like um, one class of the point may be scattered along the way. So, paano natin siya i-separate? How can we create a boundary out of this? No, unlike the example earlier, so we can easily identify the hyperplane or the decision boundary right away. But by this, no, so paano kaya? So we have here the kernel trick, no, so that can be used to project the original data points in a higher dimensional space in order to make them linearly separable. So in that higher dimensional space. Okay. So consider these two types of data points here. So we have the square one and we also have here the circle. No? So by doing that, this so so hindi man natin siya pwede ma-separate. So we can actually create a line here, a curved line here. No? So something like that. Just to separate the two glasses. And then that is in a two-dimensional space. But if we're going to create a n-dimensional space out of this, no, so parang yung two circle points natin, nasa taas siya. And then the other square points is nasa baba. So it is actually like this, no? Dito sa right side na graph. So as we can observe, no, the points that is above this plane, this square plane, separate, this plane actually separate the 2 points already. So yung sa taas at saka sa baba ng plane. So SVM are more commonly used for classification problems, no, so that has been extended to support multiple classes. Of particular importance is the use of different kernel functions via the kernel parameter. So a powerful radial basis function is used by default. No? So still by using the scikit-learn, to create an SVM model for classification. For example, the target variable is discrete, and for regression naman, which is for those target variable, which is of course continuous. Okay, so let's try here. So for this example, I use this the Pima Indian diabetes. So basically, this is a classification na dataset. Okay, so let's try. Ayan. So using SVM with the Pima Indian diabetes dataset. So it yielded um, a mean value of 0.76. Okay, then how about for regression algorithm? So by this time, I am using a different data set, those target value, which is continuous. So I am using the housing.csv. Okay, so it has a squared error. So meron siyang negative 72.25. Okay, so no, so as a recap, no, ang squared error will yield a negative accuracy result. Pero pag ano siya, pag absolute, so it could be um ano siya, non-signed value. Okay, so you just have to use SVR. No? Model is equals to SVR. And then, of course, you just have to import. It's to learn that SVM import SVR as well. Okay, so that's, I think, is for SVM. So, ayan, so at least we already know and understand the concept behind SVM. Ayan. Okay, so our next algorithm will be artificial neural network multi-layer perceptron, or MLP, ANNMLP. So artificial neural network, this is actually more, kumbaga, mas ano siya, a more common than of the other algorithms. All right, as you can always hear of artificial neural networks when machine learning or deep learning is concerned. So in ANN, computational model inspired by the way biological neural networks in the human brain process information. So there could be a terms like, for example, neural. So we can actually say that term is more on our brain, right? Mga neural or mga neurons, something like that. It is because ang concept niya plus INN is actually based on how our brain processes information. So in ANN, it has the ability to learn from the mapping function from observed training data. No? So ang predictive capability niya comes from the hierarchical or multi-layered structure of the network. So, ayun, so ang concept niya class is actually based from our biological neurons. So as you can observe here, sa brain natin is we have the nucleus, the cell body, the axons. I don't know how to explain this or expand this, but the thing is that we have neurons, and then meron siyang terminals here, which could be an output naman sa atin. No? So this is like something, like for example, when we say the month is June, July, or August, we can always say that during this month it will always rain, right? So it is already what we have learned, no? So basically, we can say that it will always rain during that month because that is what um, what we have experienced before, or historically, it is really what the weather will be during those months. Now, so that predictive capability that we have, so that is actually based from the neurons that already what we have in our brain. So we have here the several terms that we really have to learn. Also, we have the neuron. So this is the basic unit of computation in a neural network. So this is also called the node or the unit. So it takes a group of weighted inputs, applies an activation function to the sum of the weighted inputs, and return the functions. Ayun. So it define how much, ang weights naman define how much influence the input will have on the output. Just like that. The bias are additional constants added to the sum of the weighted inputs. So we have the weights and the bias. But then, so the main objective here is to identify first the weights and bias. That can be applied to, to the features or values we have in order for us to predict something or to have an output. And here we have the activation function, which defined as a mapping of the sum of the weighted inputs to the outputs. Okay, a network of neurons. So they are actually arranged into a network of neurons. So we have here perceptron, feed forward, radial basis network. We have the deep feed forward, recurrent neural network or RNN. So there are a lot of architectures of neurons in the network, and we call that as a network topology. So you can use any of this, no, for our ANN. So meron tayong LSTM, GRU, AE, variational denoising, sparse, and others. Okay, so a row of neurons is what we call a layer. For example, input, hidden, and output. And then a network, any of the network mentioned, could have multiple layers. uh, Input, hidden, and output neurons. And then this input layer can holds the data the model will train on. uh, and each of the neuron and the input layer represents a unique feature in the data set. So for example, we have petal width, petal length, or sa ano naman sa diabetes we have yung sa insulin, age, and others. Then the neurons in this layer simply pass the values to the next layer. So ano yung next layer? The hidden layer. And then from hidden layer to the output layer. So the layers after the input layer is called the hidden layers because they are not directly exposed to the input. No? So intermediate processing and computation are done on these layers. So hidden layers. And then of course our final output, which is the output layer, the final layer pala. which is the output layer. So it receives input from the previous hidden layer, applies an activation function, and returns an output representing the model's prediction. So the choice of activation function is constrained by the type of problem you are modeling. So yung activation function could be a sigmoid, Gaussian, tan H. So depende. So you can actually do like trial and error. So you could have it like using sigmoid and then find out kung ano yung accuracy niya if you're going to use that. How about sa Gaussian? So you can actually choose between those by trying to create a model with it with the corresponding different type of activation functions. Okay, so itong multi-layer perceptron is a type of feed-forward neural network. Ah, So, ano yung characteristics nito? So, the connection between the units do not form a cycle. So, information moves only in one direction, forward, and then connected series of nodes, directed acyclic graph, where each node represents a function or a model. So, in MLP, it consists of multiple layers of computational units interconnected in a feed-forward way. So, di na siyang balik class. So, forward lang, feed forward. So, weighted input. So, an input to a neuron is the sum of the weighted outputs from all the neurons in the previous layer. No? And then, synapses connects neurons. Each connection has a unique synapse with a unique weight attached to it. Okay. So we have here inputs, then with the corresponding weights, then sum of the weighted inputs and the bias with the nonlinear activation functions, and then the output. Okay, nonlinear model patterns in dataset are nonlinear. So we also have continuously differentiable. So to improve model using gradient descent, output must have a nice slope. So error derivatives with respect to weights can be computed. So we also have an activation function, which is fixed range. So squash the input data into a narrow range. Okay, so we have here examples of activation functions. So we have unit step, signum. So the graph would look like this. We have the piecewise linear, logistic or sigmoid, hyperbolic tangent, tan H. We also have ReLU, and we also have soft plus. Okay, so with the different activation functions can be used with its corresponding equation here, and then examples and the graph. So the choice of activation function in the output layer is determined by the type of problem. So depende siya. So yung multiple classification problem may have a multiple neurons in the output layer, one for each class. Then a regression problem may have a single output neuron, and the neuron may have no activation functions. Okay, so yung multi-class classification could have multiple neurons. Yung regression naman could have single output neuron lang. So, for example, sa diabetes, so you could have two output, no? Like whether it is non-diabetic or diabetic. Okay, training neural networks. So, of course, we have the data preparation. So, the data must be numerical, no? Categorical data can be converted into real valued representation using different encoding techniques. Like say for example, ang color red is 1, color blue is 2, color green is 3, or color blue is 4. Or it could be like separate mo siya into different columns, and then if it's color red, put it 1. If it is not naman, 0. Blue, put it 1. Green, put it 1. So depende. You could have it like this, or you could have it like this sa other representation. So scale between a range, no, or normalization. So pwede siya na scaled, i-normalize mo siya class from 0 to 1 values. So standardize the distribution of values of each column to have a mean of 0. Okay, so making predictions, input data is forward propagated. So through the network layer by layer to the final layer which outputs a prediction. So this is what we call a feed forward phase. So dire-diretso siya. Hindi siya mabalik class. Okay, for step 1, the values received in the input layer are multiplied by the weights. And then, of course, bias is added to the summation of the inputs weights in order to avoid null values. And then, next step is each neuron in the first hidden layer receives different values from the input layer depending upon the weights and bias. And neurons have an activation function that operates upon the value received. So it could be sigmoid, ReLU, or tanh. Then the outputs from the first hidden layer neurons are passed to the neurons of the preceding layers. And of course, the process continues using the activation function again until the output layer or the outer layer is reached. Then the predicted output is not necessarily correct right away. So pwede siya, it can be wrong. Then to improve predicted results, a neural network will go through a backpropagation phase. So weight updates. So we use a loss function to estimate how good the model is at making predictions for a given set of parameters. Then the loss function has its own curve and its own derivatives. Then the slope of these curves tell us how to change our parameters to make the model more accurate. So gonna change until it will yield a more accurate results. So ang goal ng backpropagation, no, is of course to i-adjust natin yung weights in the network in proportion to how much it contributes to the overall error. Then we iteratively reduce each weight's error, and eventually we'll have a series of weights that produce good predictions. So one round of updating the network for the entire training data set is called an epoch, or yung iterations. Okay, so we have here an example of the neural networks. So the input, we have three rows, one column. So three rows of training data and each row has one attribute. Okay, so sa hidden weight naman, see we have one, two. So these dimensions are based on number of rows equals the number of attributes for the observations in our training set. So yung number of columns equals the number of neurons in the hidden layer. So the dimensions of the weight matrix between two layers is determined by the sizes of the two layers it connects. So there is one weight for every input to neuron connections between the layers. And then we have the hidden bias. So each neuron in the hidden layer has its own bias constant. Now, so this bias matrix is added to the weighted input matrix before the hidden layer applies the activation function, which is here the ReLU. Then we also have here the hidden weighted inputs, this one. So it is computed by taking the dot product of x and hidden weight. So the dimensions are required by the rules of matrix multiplications. So the hidden weighted takes the rows of the input matrix and the columns of weight matrix. We then add the layer bias matrix to the hidden bias. And then we have here the hidden activations. So computed by applying the ReLU functions to hidden weighted inputs, no, hidden weighted inputs. So the dimensions are the number of rows matches the number of training samples and the number of columns equals the number of neurons. So each column holds all the activations for a specific neurons. And then we have here the number of rows, which is the output weights. The number of rows matches the number of hidden layer neurons and the number of columns equals the number of output and output layer neurons. So there is one weight for every hidden neuron to output neuron connection between the layers. Then we have the output bias. Finish class. BO. Sana yung BO? Ay, narin eh. Output bias. So there is one column for every neuron in the output layer. Then we have the output weighted input, ZO. So computed by taking the dot product of H and W output weights and then adding the output layer bias. The dimensions are representing the rows in the hidden layer matrix and the columns of output layer weight matrix. And the output activations, each row represents prediction for a single observation in our training set. So each column is a unique attribute we want to predict. No? The example of two column output predictions could be a company's sales and units sold or a person's height and weight. Okay, so I think that's all for ANN multi-layer perceptron. So let's have an example. Okay, so load the data. So by this example, I am using the iris.csv. Okay, this is the example instances. The classes we actually have three classes for this. So class 0, class 1, and class 2. So we transformed our non-numeric class to a numeric one. So 0, that represents a class, and then 1, another class, then 2, another class. So tatlo siya. Then train the model. Okay, so we have here the actual and the predicted output. And then that's it. Okay, so that's all for our discussion today. And if you have any questions, you just don't hesitate to PM me or drop it in our chat box or our group chat. So once again, good morning and have a good day, everyone. Thank you so much.